Welcome everyone, good afternoon, and this is the third video as a preview of SP1. I'm always Paolo, and I will actually show you a few things about the hydraulic systems today. Out of the hydraulic system before that, I will show you a few more things related to main features we actually slightly modified or improved from the hotfix version of this SEM 4. First thing ever is the oxygen pressure. Oxygen pressure, as you can see, is showing 1789 psi on both sides, while before hotfix 1 those values were always the same one at 1750, if I remember correctly. It was stuck in one value, I'm quite sure it was 1750. We modified it for SP1 and we now have random values from flight to flight, and those values can also be lower, higher, depending on the outside temperature, or of course changing with the aircraft, because of course it's more realistic if you use 747 from Virgin. Will be different from using, say, pressure on the British Airways. It will be of course different because of the bottles, because of the system, because of the pipes or the sensor. Those values of course will change from flight to flight, and so you will have to check them before the flight to be sure those values will be into the valid limits for the flight. The vast majority actually will be always into the limits, because we didn't want to create problems with new users, of course, but those values can actually be lower, and if you want to refill it, you have to have parking brake set, go into the zero menu, go to the ground support, and of course page 2 or 3 you will have oxygen, and you can enter oxygen fuel, press it, and you will get full PSI onto the pressure system, onto the oxygen system, sorry. Of course this is a small change compared to the past. We also but it actually rendered the aircraft much more realistic about that, so you have to check it, and when you do the oxygen check you will check the pressure, you will check is into the dispatch limits, and they will say okay, well, let's go, that's fine, we can continue. Out of the oxygen pressure we changed few textures around the cockpit, mainly for a few flight operating manuals that were the front page were strange, or I would say not perfect texture. We corrected a pair of textures that were not perfect. They were really small errors, so you probably won't notice them first time. Maybe you will see it while flying around the virtual cockpit. Mainly we changed some of the library textures, some of the left-hand captain side for the manual sections, and a few more things you will see while playing with the virtual cockpit. Anyway, talking about the hydraulic system. It's now time to talk about the hydraulic system. Oh, sorry, I forgot one thing earlier. That if we go back to menu and simulation, we now have on the page 2 out of 2 intelligent cruise. Earlier it wasn't possible to access that from simulation menu direct. Actually, you had to actually go to panel style and intelligent cruise. Now we can actually access from here, and we change a pair of things. So, for example, you can have auto fuel balance also with realistic timing, while it earlier was only with 2 pair, 4 pair or 8 pair rate while flying the 74. This was requested also on the forums, and I'm quite sure I saw a post asking about if auto fuel balance was available with 1 pair time compression, and I will say yes, it is. It's new, can be done. Of course you can change all the values from this page if you need, and you can access almost everything on the config tool actually from the CDU. Anyway, this was just a small change. Now it's time to think about the hydraulic system, so we can go to the hydraulic page for the CMC. I will not turn it on yet because we have all the values there, as you can see: hydraulic quantity, hydraulic pressure, hydraulic temperature. If we go to the CMC, well, just a second, I will show you the hydraulic page. As you can see, reservoir pressure normal on all 4 of them, so it's not problematic in this case. Hydraulic quantity showing 99-98% on all the 4 systems. Hydraulic pressure, the system is not pressurized, so as you can see 60 psi in all, and the hydraulic temperature is 15-16 degrees. It's quite close to the static air temperature, outside temperature. This is the first change we did actually about the hydraulic temperatures, because before hotfix 1 those temperatures were quite around 40 degrees even with the system not pressurized. Now it's much more realistic, because those temperatures are closer to the outside air temperature, and of course depending on where is the sensor, depending on the pipes and on the system, if the sensor is close to the aluminium, aluminium cover of the wings, for example, you will have a higher temperature, just like 18 degrees. But if it is in the main fuselage down near the fuel tanks where it's getting colder, you will see maybe 14 degrees instead of 15. And this is more realistic, and of course the changes are being reflected by the outside air temperature. If you will be in Dubai, probably those temperatures will be higher, of course, 40 degrees or something like that. We are now around London, so you will not see much difference from 15 degrees at this moment. This is the first change we did. This is the CMC page, and as you can see, CMC page actually show the same values as the main hydraulic page, so we will keep using the main hydraulic page to show you quite more information for the crew. We are looking now at the overhead hydraulic panel. As you can see, engine pumps are off, demand pumps are completely off, and all the lights are on. Situation is APU is actually on, but not bleed air. APU bleed air is on. First thing I will talk about is how they are actually driven. Engine hydraulic pumps are actually mechanical. They are connected to the auxiliary gearbox that is usually located beneath the engine, powered by the compressor stages, where with some gears actually, and of course transmission gears that change the rotational speed, you will get actually those mechanical pumps to work together with the electrical IDG, just like a integrated generator, oil pumps for the engine, and a lot of more stuff in the auxiliary gearbox. Demand pumps are actually the backup pumps for the 747. 747, differently from other aircraft, has a lot of backup on the hydraulic system. This can be seen because system 1 and 4 demand pumps, main demand pumps, are actually powered by bleed air, so actually coming from the bleed system of the aircraft. While engine 2 and 3 demand pumps are electrics, so they just need AC power to be from the bus 1, I guess. I'm quite sure it's bus 1 for the number 2 and bus 2 for the bus 2 and bus 3, because we have 4 engines. Sorry for that. And they need of course AC power. We have another selection for the number 4, that is auxiliary. Auxiliary is an electrical backup pump that is required because if you pressurize the system from 1 to 4 without pressurizing system 4 earlier, you will get fluid transfer between the hydraulic systems. And this is something that we don't really want into an aircraft, because mixing the fuel can actually create a problem on 2 systems or more systems if the fluid is contaminated is just one system. So we just keep all the fluid in each system, not to mix it. We now will set the APU on, come back to the ECAS page and show you the main ECAS page for hydraulic. Okay, we have now selected the ECAS hydraulic page. As you can see, we have the same values as before, so 99-98%, PSI 60, all the pumps are completely off. The level of the reservoir, as you can see, is the green bar, and we have an indication of reservoir pressure. Why? The reservoir for the hydraulic fluid is slightly positive pressurized. It's nothing compared to pressurization into the aircraft or pressurization, heavy pressurization. I mean, it's just a little bit of positive pressure. This is done because the pumps for hydraulic fluid suffer from cavitation if you don't have a positive pressure coming out of the reservoir. If you create a positive pressure, there is always a flow of fluid, or hydraulic fluid, going into the pumps, and for this reason you will not get any overheating and not any pumps trying to work on air that of course is not possible for centrifugal pumps like they are on the hydraulic systems, and of course they prevent cavitation. Anyway, this was just smooth. As you can see, we have reservoir pressure showing. Reservoir pressure is normal, we get some pressure of course, but in fact is in white, but it's not the pressure we want to, because the reservoir pressure is being taken by the engine bleed air direct from the main manifold, so up to the point you will not start the engine, you will not see this alert going out. Anyway, as you can see, all the engines are off, all the pumps are off. You will see ADP off, demand pumps off, and SOV, that is shut off valve, in case you just pull the fire lever. In a case of fire, just shut off completely the hydraulic system. We can now go to the overhead, set up the panel for a normal engine startup, and I will show you without having a APU bleed air what happens. So for an engine start, we want actually to have the engine ADP pumps to on, just because when the engine starts, actually they get the priority over the demand pumps, and then we can pressurize the various pumps. For example, engine pumps 4 we can set to auxiliary to prevent engine fluid, and then we can set pump 1, 2, and 3 to auto. This is the engine startup configuration when you actually having to do the pushback and the startup. As you can see, there is different configuration for the lights depending on what is the selection. We will start with the one that is quite different, the auxiliary position. We have just no system fault because we actually got pressure into the system, but we have a pressure light. Why? Because the sensor for the low pressure light is actually into the main demand pump pipe, so actually when it's using the pneumatic pump. And of course we have pressure, so system fault is off, but we still have the low pressure because there's no pressure into the pneumatic pump pipe, but this is in the electric pump pipe. Same, quite similar is for the pump number 1. Pump number 1, demand pump number 1 is only pneumatic, so you will not have any pressure without APU bleed air, and for this reason you still have no pressure and low pressure on the pipes. While for example demand pumps 2 and 3 have electric power, so they're working perfectly, giving the pressure, and there is no system fault at all. If you go back to the main panel, I'll show you the ACAS. You will see now the configuration of the various pumps and the systems. As I told you, auxiliary pump number 4 is on. The pressure sensor is on this side of the pump, so as of course is showing us low pressure. We have the two demand pumps 2 and 3 working perfectly. And as you can see, there is no anymore the off into the ADP because we actually turn it on. It's waiting for the pressure to actually switch to the main engine driving pump. System 1, as you can see, no APU bleed air at all, so it's not showing anything and is completely depressurized for the system. If we now go back up and we set the APU bleed air on, and we can set APU bleed air on, coming back to the main panel. As you can see, no more system fault or low pressure lights, and now demand pump number 1 is working perfectly, and we have pressure. As you can see now, I was talking about the temperature just a few minutes ago, and as you can see now the temperature is 51, 54 depending on the outside temperature and of course of the pumps pressurizing the fluid and getting it warmer. 50 degrees, 50 degrees, 40 degrees is quite realistic value for that, so we actually change it to make it possible to see 16, 15 degrees when you have outside temperature, and then when you pressurize the system, temperatures goes up because the fluid start to move around the system, and realistically is showing you 50ish degree or around that. As you can see now also we changed slightly the pressure of the systems. Pressure is around 3000 psi. Of course there is a range of values that is possible between 2950 to 3050, and it's quite realistic one, and they actually of course they are changing, and as you can see they are slowly changing from time to time, and these changes are quite realistic, they are quite fast. We change the timing for that, we change the model for that, and we model them quite nicely. Coming to the big part we change for the hydraulic system, when you activate the flight controls, of course, because you actuate the flight controls, actuators moves, valves open and or closes, hydraulic fluid is moving into the pipes, and the situation is less stable than when the flight control are stuck, are of course stable and in the same position. You will see the pressure moving actually fluctuating faster. That happens of course because moving the controls, more fluid going around, there is more fluctuation onto the movement of the controls, and I will show you. As you can see now we are in a stable condition, we are not moving any controls, but if for example we move the controls to the left, full aileron to the left, you will see the pressure moving faster. I will start moving it now, and as you can see everything moves faster, showing actually that the pressure is stabilizing and now is slowly coming back to a stable condition. Same things, moving the page down, you will see moving all to the right, pressure is fluctuating much more and then pitching up. And then when you release the controls like now, you will see the pressure to slowly stabilize to a value and then changing back, as you can see now, to a more stable condition. It's quite realistic. We modeled realistically, just to show you fluctuation of pressure when you actually move the controls more than when you are stuck in the same condition. Of course, those are all things you will probably won't notice without being told you, but we are trying to make it as realistic as possible, and this is quite a nice thing to see because we managed to do it more realistically. And that's one of the reasons why SP1 is taking a lot of time, because we decided to do a lot of stuff. Team worked very hard to get all the improvements, so we are just now coming to the quite close to the SP1 we want to deliver to the users. At this point, I will turn on the engine, show you what happens when the engines are on, and then I will show you 2 or 3 failures on the hydraulic system to show you some of the failures you can actually select on the 7.4 as the failure module we modeled for. I will be back when turning on the engines. In a few seconds you will see, of course, but I will show you what happens when the engine starts and they switch to the EDP pumps. Okay, we are now starting engine number 2 and 1, while engine 3 and 4 are actually still turned on. What you will see now is the switch from the demand pumps that will stay in auto, as you saw now, to ADP because the engines are on. And now, of course, the pressure is kept. Reservoir pressure alert is not anymore there, of course, because we got APU bleed air from the engines. So the reservoir is using this pressure to pressurize the reservoir, and all the systems are quite to the normal situation. We just need to switch the demand pump to auto for engine number 4, and then we are in an after startup situation. Okay, as you can see, demand pump to auto. Low pressure indicator is off immediately, and this panel is actually selected as supposed after takeoff. Okay, we are now thinking about what to do after the startup and everything is on. As you can see, I show you everything. I will show just few things we can do with the failures on the hydraulic system. What we can do actually as a failure, of course, we can go to the hydraulic system that is on page 3, hydraulics, and as you can see there are plenty of possible failures you can select. One thing we can, for example, show is the leak on the systems. If we just go to the hydraulic one, leak, because system 1, we will just fail system 1, we can select 0 minute and it will happen immediately. You will see the quantity going down, the level of the green bar going down, then you will see below 75% refill indication, and after the refill indication you will see all the quantity going down, pressure starting to fail, caution going on, and you will see a yellow bar instead of the green one. You see refill below 75, then it's going down. When it passes the level, it's around 40ish, when actually the main pipe can actually go in. You see 40, 35, now the reservoir pipe is not possible to be used anymore, pressure is going down, temperature is going down, and we lost the entire quantity, and of course we lost the entire system. And in this case we lost pressure, demand pumps cannot go in because of course we don't have any fuel and fluid, and this system is completely lost. If we do, for example, another failure, for example we do for engine for system number 2, we just failed the engine driven pump. We'll search it here, I will select 0. Of course the automatic substitution of the demand pump will just come in and will show you the demand pump being used instead of the engine driven pump. It says 0, okay, we see demand pump are now getting the pressure, and we have a yellow indicator showing low pressure on this side of the system. If we just, for example, let's fail the demand pump while the main engine pump is working, we can actually go to hydraulic 3 demand pump. This is of course the system we want to try. We can select 0, and as you can see now we have a yellow auto indication that say, oh, the demand pump is in auto position but is not working. There is a failure being sensed by the system. This is more or less what you can do with the hydraulic system, and all the various things you can do, or you can actually select off failures later. And it's quite nice to see everything can be done actually on the various system. And for example, the last failure I can do is just like 0 on the aux pump. You will see no alert at all, because of course aux pump is just auxiliary pump, but if you select auxiliary pump, it will not work. That's enough for today. I think I showed you the vast majority of the hydraulic system and a pair of more things we had it for SP1. I hope you enjoyed the video. Next one will be air conditioning and pressurization if everything goes as the plans. But of course, remember that we are trying to work on the SP1 now, so if I have time to do it, probably will take more than 1 or 2 days like the last few videos I did, because there is quite more things to do and to show you, and they are quite to be shown during flight, so I need to set up a flight and show you going in flight for that. Anyway, in any case, we are still working on some of the things you may have seen into the video, so if you see something strange, it can happen, of course. We are aware of that. We're working a little bit on the air conditioning pressurization. There are a pair of things still to be corrected, but we are working hard on that, and be sure we are gonna deliver the SP1 as the best as we can when it's ready. So just wait for that, keep tuned on the forum, and wait for the next video. Thank you for watching, see you, and have a nice weekend.